Hello students, I welcome you all in the quick solutions of All India Akash Test Series Medical 2019, and we are just going to discuss the test number 4 code A and B. We will be dealing with the chemistry part of the test 4. Let's begin with the very first question. That's question number 46. Let's have a look on that. If Avogadro number Na is changed to 6.022 into 10 raised to the power 22 per mole, then this would change. Basically, we know that this Avogadro number Na is equal to 6.022 into 10 raised to the power 23. What it represents? It represents the number of particles in 1 mole of the substance. So this is representing 1 mole of an ideal gas at STP, and in that the number of particles are 6.022 into 10 to the power 23. Now what we are going to do here, we are just going to change this Avogadro number to 6.022 into 10 to the power 22 per mole. It means you are just going to change the number of the particles which are present in 1 mole. So what it will cause? Let's see the options given here. The ratio of number of atoms of different elements in a compound. If we have a certain chemical formula of a compound, and if we have a certain chemical formula of the compound that represent the ratio of the number of atoms present there. So it means if you change the Avogadro number, there would not be any effect of that on this ratio of number of atoms of different elements in a compound. So this would not be the option. Further, the ratio of stoichiometric coefficients of chemical species in a balanced chemical equation. There would not be any effect on that, because we know that Avogadro number represents the total number of the particles present in 1 mole of the substance. So there is no change of ratio of the stoichiometric coefficients of chemical species in a balanced chemical equation. Then we have the law of conservation of mass that states that mass can neither be created nor be destroyed in a chemical reaction. That would also not be changed. Let's check the next one. The mass of 1 gram atom of carbon. So if we talk about 1 gram atom, what it represent? It represent 1 mole of the substance. And if you change the Avogadro number, definitely the number of the particles present in this 1 gram atom would be changed, and on that basis the mass of 1 gram atom of carbon would also be changed if you change Avogadro number. And on that basis we can say that this is the option which is correct for this particular question, and that's why I'm just writing here the answer, that is option 4. Let's take next question. Question number 47. How many grams of concentrated sulfuric acid solution 80% weight by weight should be used to prepare 500 ml of 1 molar H2SO4? So what you need to prepare here, you need to prepare 500 ml of 1 molar H2SO4. The molarity is given, concentration is given, total volume is also given, but you need the mass of that sulfuric acid. Simply we know that the molarity is equal to moles of solute divided by the volume of solution, that should be in liter. So on that basis, what we need here, we have 1 molar concentration already. N is the number of moles divided by the volume, that should be in liter, but we have it in ml. So that's why in this case the number of moles would be, what would be the number of moles in this case? This would be 0.5 moles of H2SO4. Now what would be the weight? We know that this N value is given mass by the molar mass of H2SO4. I'm just writing here mm for molar mass. So this weight you can calculate on the basis of this would be number of moles into the molar mass, that is 98 gram per mole, and it would be 49 gram. This is basically the amount of H2SO4 that you need. But the one thing that's remaining here, but the sulfuric acid that is given to you is 80% weight by weight. It means you need more amount to prepare that particular solution. So what would be that amount? We know that the given acid is 80% pure. Further, 80 is equals to that amount that is given here, and let's assume the total mass of H2SO4 that you require there is W, and on the basis of this we can find out the value of W also, that W is equals to 49 by 80 into 100. And if you solve this, you will find out that this mass is 61.25 gram. And yes, if it is so, you can easily choose third option as the correct one. And that is my answer also. Now, let's move on to question number 48. Question number 48. The number of atoms in 0.25 mole of a tetraatomic gas is. Here, this Na represents Avogadro number. Why this Na is given? Because answer is given in terms of Na, Avogadro number. In this case, you have 0.25 mole of a tetraatomic gas. It means one molecule of that gas contains 4 atoms. So, if one molecule of gas you have that contains 4 atoms. Now, in the simple way, 0.25 moles means 0.25 into Na molecules. We have just changed the given amount into the molecules. 0.25 Na molecules if you have, then definitely the number of atom would be 4 into 0.25 into Na. And if you solve this, definitely you will find out that this is Na number of atoms. These are the atoms here. Now, on the basis of this, third option is the correct answer, and that's why you should choose it as the correct option. Let's take next question. Question number 49. The mass of precipitate Ag2CO3 formed when 50 ml of 21.2% weight by volume solution of Na2CO3 is mixed with 100 ml of 17% weight by volume AgNO3 solution is. And in this case, very good hint is given that molar mass of AgNO3 you have, molar mass of Na2CO3 you have, as well as the molar mass of Ag2CO3 also you have. So the reaction that's taking place here is the mass of precipitate Ag2CO3 which is formed when these two are mixed. What are these two things? One is Na2CO3. It's mixed with another thing, that is AgNO3. The reaction will take place to form NaNO3 in the solution and the precipitate of Ag2CO3. This is basically the precipitate that you will obtain. Now, you want to find out the mass of precipitate formed when 50 ml of 21.2% weight by weight. So let's find out the amount of this Na2CO3. This is 21.2% weight by volume. And what is the volume here? It is 50 ml. Let me mark it here. This is 50 ml, 21.2%. So this mass would be, this W would be equal to 21.2 into 50 divided by 100. So this is the weight of this Na2CO3. Similarly, if we talk about AgNO3, what would be its weight? It's given here that the 100 ml of 17% weight by weight you are taking here. For this AgNO3, the simple thing is you have 17% weight by weight solution. And what is its amount? This is 100 ml. So this weight of AgNO3 would be equal to 17 into 100 by 100. So this value is equal to, if you solve this, you will find out it is 10.6 gram. And then the similar manner, if you want to find out this value, this would be equal to 17 gram. Let's find out the moles of this. Mole is equal to the given mass by molar mass. So let's divide this given mass by molar mass to find out the moles of Na2CO3. It would be equal to 10.6 divided by the molar mass, that is 106. And how many moles would be there? If you find out, it would be 0.1 mole of this Na2CO3. So I'm just going to place it in box further. If we talk about this AgNO3, the moles of AgNO3 would be equal to given mass divided by its molar mass, that is 170 gram per mole. So it would also be 0.1 mole. Now just have a look on the given chemical reaction. If you look at the given chemical equation, you will see that, let's balance this also. In this case, you have to take 2 mole of AgNO3. On the basis of stoichiometry, you can solve this. Let's check and compare the moles. If you look at the chemical equation, 1 mole of this Na2CO3 requires 2 mole of AgNO3. It means for its 0.1 mole, which are given in the question, require 0.2 mole of AgNO3. But it is not given. It is only 0.1 mole. That is why, what is the limiting reagent in this case? Definitely in this case, the limiting reagent is this AgNO3. I'm just writing here, this is limiting reagent. And if it is limiting reagent, it will decide the amount of the precipitate formed. If you look at this given equation, you will identify that 2 mole of this AgNO3 are preparing 1 mole of Ag2CO3. On the basis of this, we can say if you have 0.1 mole of AgNO3, then definitely 0.1 by 2 mole of this Ag2CO3 would be formed. And what would be the mass of this? This mass of this would be given moles. That would be 0.05, because if you divide 0.1 by 2, you will get 0.05, and then multiply it by the molar mass of Ag2CO3, that is 276 gram per mole. And if you solve this, you will find out that this amount is equal to 13.8 gram. And yes, this is our final answer also. So where it is given, just have a look. You will find out that it is given in option 4, and this is our correct answer. That's option 2. After this, let's take next question. The volume occupied by one molecule of ethanol is. The density of ethanol is given here, on the basis of which you just have to find out the volume. And we know that density is equal to mass by volume. So in this case, you need mass. You have to calculate volume on the basis of density. We know that if we talk about this ethanol, in case of ethanol, the molecular formula is C2H5OH. So what would be its molar mass? This is 46 gram per mole. It means what it represents? It represents that mass of 1 mole. So what would be the mass of one molecule? You have to divide that mass by Avogadro number to find out the mass of one molecule. So on this basis, we can say the mass of one molecule of this ethanol, that is C2H5OH, it would be equal to the mass of total 1 mole divided by Avogadro number. And this would be in grams. Now you have the mass of one molecule. You have the density. You can find out the volume. So what would be the volume? Let's check here. The volume is equals to mass into density. Mass of one molecule is 46 divided by 6.022 into 10 raised to the power 23. And then multiply it by the density. That's also given. It is 0.8 gram per centimeter cube. It means the volume that you are going to take here would be in centimeter cube. If you solve this expression, you will find out that the density would be equal to 9.55 approximately 10 raised to the power minus 23 centimeter cube. This is the volume of one molecule. Let's find out the answer where it's given. It's given in option 1, and that's why you have to choose it as the correct option. Now, after this, let's take next question.